Chapter 1, Introduction to Computer-Aided Design. In this chapter, student will study the importance of computer in design of engineering product. The chapter also deals in brief with computer fundamentals. The computer-aided design process is discussed in detail to give insight into use of computer as a tool. Learning objectives. Learners will be able to know the use of computers in the design of engineering product. Learners will be able to identify units of computer. Learners will be able to understand the importance of computer-aided design, that is CAD process. Introduction to computer-aided design. In computer-aided design, CAD subject, the use of computers in design is studied. Before understanding the fundamental concept of CAD, it is essential to know the purpose of design in any manufacturing industry. Once the design process is thoroughly understood, it is easier to know the use of computers in it, that is CAD. Para 1.1, Need of Machine Design. In the product manufacturing industry, design and manufacturing are the key phases. Once the design is finalized, the part is manufactured. The manufacturing involves process planning, machining, and quality control. In the design of product, design parameters are decided, which are useful in the manufacturing of the part. For example, in the case of shaft design, the diameter of the shaft, the material of the shaft, etc. can be considered as design parameters. After manufacturing, the part is marketed. The diagrammatic representation is shown in figure 1.1. If figure 1.1 is studied, it is felt that based on the demand, the part will be manufactured and it will be marketed. Figure 1.1 is likely to take shape as shown in figure 1.2. Thus, the need for the design in the manufacturing unit is questioned. Is it that the design of the product is done once and then subsequently it is not needed to set the cycle moving in the industry? This is not true. The following 2 points explain the need for the design process in the industry. Number 1, human comfort. Number 2, competitive environment. Para 1.1.1, Human comfort. Every human being, consumer, strives for more and more comfort in his or her life. The best example is the home television set. Color televisions replace the black and white televisions. The color televisions are then equipped with remote control set, and now even automatic tuning and volume adjustments are handled. All such development is in the offing because of the basic tendency of the human being to demand more and more comfort. For adding the feature in the product so as to add to its value from the human comfort point, change in the design of the product is must. Thus, figure 1.1 still holds good. Para 1.1.2, Competitive environment. Because of the liberalization policy followed in the world, the market scenario is very much competitive. The product coming out of the industry has to compete with the product not only from the local area but from all over the world. With the rapid progress of e-commerce, the competition will be stiff. The market is becoming price conscious and consumer is a king. The sum of the parts is less than the whole. This is the mathematics of price conscious market where less means more to the consumer. A cut in the cost is the biggest plus. Manufacturers all over the world are rapidly working up to this new reality. The consumer wants more for less. They want their money to work harder. This implies that manufacturer needs to work harder to offer more features, more value to the product. And the only way that is possible is through engineering design. Thus, engineering design must be given due attention in the manufacturing industry in order to sustain in this competitive environment. Though both the points are discussed separately, they can be taken as one because the feature that are added to the product for human comfort prove equally beneficial in a competitive environment and vice versa. It is therefore necessary to elaborate figure number 1.1 from the concept discussed above, that is, if the design is important in the cycle, how the cycle operates. Details about the design cycle are discussed in chapter 5. It is already mentioned that the design parameters help in manufacturing the part. The part after manufacturing is marketed. The marketing professional sells the product and also gets information about the performance of the product. This information is given to a design engineer who takes care to modify the design as per the consumer's demand. Para 1.2 Why computer? The modification in the design is the crucial step in the manufacturing industry because it affects all the phases in the industry. The design engineers need to consider many factors before the modification in the design which is finally implemented. Some of the elements are: number 1, how best the change in design satisfies the consumer as per the feedback received from the marketing professional. Number 2, whether modification can be done without any change in manufacturing setup as established for the existing product. Number 3, whether human resources with existing skill can carry out this modification. Number 4, how fast the products with such a modification in the design come out in the market to beat the competition. Out of these factors explained above, the last one, that is how fast the product can be launched in the competitive market, is crucial. This is because the consumer will be occupying an essential and demanding position in the market, so that he will be evaluating the product from his viewpoint. The product not only needs to be launched earlier but also needs to satisfy the consumer. Looking at this situation in the manufacturing industry, the design engineer has to test many design alternatives before finalizing any modification. The design procedure that involves a lot of technical, mathematical, and thinking models becomes more tedious and stressful when such time and quality constraints come into the picture. In the earlier period, such constraints were not there, and therefore the design engineers could manage to handle his office with calculators and drawing boards. Computers now replace calculators. The essential features of computer is not only getting mathematical operations speedily, but also the execution of the algorithm developed using well-built logic. The design engineer can handle the entire task which he was doing earlier and even more with the computers at a faster rate. This helps him to carry out his prime task of design modification quickly. For the design engineer in the manufacturing industry, having mechanical or production engineering background, knowledge of computer is a must. Para 1.3 Computer Fundamentals. The computer system consists of 3 parts. Number 1, input. Number 2, processing. Number 3, output. It can be represented diagrammatically as shown in figure 1.3. The input or data to the computer system through input devices is either alphanumeric or pictorial. The data is processed in the central processing unit CPU. The result obtained after processing the data is shown on output devices. A simple example is the addition of the two numbers, refer figure 1.4. If the addition of the two numerical numbers, that is 2 and 3, is to be found out on the computer, then input or data are 2 and 3. Processing of this data, that is addition, which gets executed in CPU, and the result 5 is obtained on output devices. It can be easily seen that the processing device is the heart of the computer. Thus, it is essential to study the processing unit, that is CPU, first. Para 1.3.1 Central Processing Unit CPU. Central Processing Unit coordinates and controls the activities of all other groups and performs all the arithmetic and logical processes to be applied to data as specified by program instruction. CPU has 3 parts. Number 1, controller. Number 2, arithmetic logical unit, ALU. Number 3, main memory, primary storage. The controller loads the program and data into the memory, examines the programming instruction, and interacts with the arithmetic logical unit to carry out arithmetic and logical operation. Refer figure 1.5. Controller. The controller acts as an administrator on computer. It examines sequentially each instruction in the user program, interprets it, and decides how and when to perform the operation. It informs the ALU what to do and where to obtain the necessary information. It understands When the ALU completes a calculation and then instruct ALU what to do with the result and what to do the next. The controller monitors the overall operation of the CPU. The controller continuously performs an instruction execution cycle. The speed at which an instruction executed is directly related to the computer's built-in clock speed, which is measured generally in megahertz. ALU. The arithmetic and logical unit deals with arithmetic and logical operation. It performs the actual work of computation and calculations. It also understands and executes logical statements. Main memory. Both the controller and ALU make use of primary memory or registers to perform their functions. These registers are small memory units that can receive, hold, and transfer the data. The main memory can store information such as program instruction to be executed by the controller and data to be processed by ALU. Intermediate results can also be stored while ALU is working on another part of the program. All the stored information and results are made available for use anywhere from the portions of the program directly addressable by CPU. Hence, the main memory is also called RAM, Random Access Memory. Generally, the size of the program written for CAD activities is enormous since they are interactive, graphics-oriented, and has to handle a large number. Hence, a large memory is one of the essential requirements for a computer system to be used for engineering design work. Para 1.3.2 Input Devices. Input devices have features for accepting data from the user. Some devices take data in the form of alphanumeric characters. As and when the characters are typed, they are transferred to the primary storage. A keyboard is one such input device. Some devices transfer the relative movement of a stylus or that of a ball to a corresponding data and pass it on the computer. Still, some devices first require data to be recorded as an input storage medium. Keyboard, touchscreen, voice data entry are few popular input devices. Para 1.3.3 Output Devices. Output devices are instruments for interpretation and communication of information from a computer to the user. It converts computer representation of data into a form which humans can understand. These devices receive the output results from the CPU. Monitor screens, printers, plotters, etc. are few popular devices. Para 1.4 The Computer-Aided Design Process. To understand CAD, it is essential to know the use of computers in the design process. The design process constitutes two main sub-processes, namely, number 1, synthesis, number 2, analysis. Para 1.4.1 Synthesis. The end goal of synthesis is a conceptual design of the prospective product. In the synthesis phase, the information regarding the design of the product is generated. The design conceptualization and design modeling can be considered as two essential steps in the design synthesis. In design conceptualization, the concept of design of part gets evolved through brainstorming discussion among various design teams and collecting relevant design information and feasibility strength. The feedback received from the marketing professional also aids in building a strong concept of design. Design modeling mainly deals with pictorial representation of the design of the product, which helps in the exchange of ideas and possibly changes in the design. The information generated during the synthesis sub-process is qualitative and therefore the use of computers in the design synthesis is hard to justify. No doubt, expert systems are some of the areas in computer science which have made a great deal of progress in this regard. Expert systems are the rule-based computer programs that solve specific problems on an expert level and provide problem-solving skills to the design engineer. For example, an expert system could analyze a part drafted on computer system for ease in manufacturing. If an excessively small tolerance is found, an expert system warns the engineer that manufacturing difficulties will ensure and suggest easing tolerance. Similarly, an expert system would analyze a design to standardize parts, for example, to make sure that an assembly use one bolt size instead of the optimum size for the each location, thereby more accessible invention and maintenance difficulties. Thus, in synthesis, the engineering knowledge and creative skill of the designer play a significant role. Instead of putting the ideas on the paper, a suitable computer program can be written to accept the views from the designer, transfer it into the computer model, and accurately represent it on the computer. This computer model can be used as a basic design to start with. Para 1.4.2 Analysis. The analysis sub-process begins with an attempt to put the conceptual design in the context of the engineering sciences to evaluate the performance of the expected product. It can be studied under the 4 phases. Number 1, engineering analysis of the physical model. Number 2, design optimization. Number 3, testing. Number 4, presentation, design communication, and documentation. Engineering analysis of the physical model. The transformation of the physical model into the analytical model and then using numerical techniques to compute the responses are the primary task of the stage. The designer should have adequate knowledge of analytical and numerical tools to be used depending on the nature of the engineering systems. The finite element analysis or finite element method FEA is the most prevalent computational method for engineering analysis. The finite element computational method replaces the complex shape with a set of simple elements interconnected at a finite set of node points. In FEA, part geometry is sectioned into many subsections or elements. The stiffness of each component is known and is expressed in terms of stiffness matrix for that element. By combining all the stiffness matrices, applying kinematics and stress boundary conditions, and solving for unknown stresses or displacement, complicated geometry can be easily analyzed. Computers help in proper analytical modeling and effective handling of extensive data during engineering analysis. Design optimization. In this phase, design problems can be mathematically formulated so that mathematical programming techniques can be used to arrive at a design with optimum performance. Optimization techniques based on mathematical programming provide the designers with robust analytical tools. It is now possible to formulate the engineering design problem as an optimization problem with objectives such as minimizing the cost or weight, subject to the satisfaction of all the conditions of design. Rapid advances made in computer hardware and software helps to solve the design optimization problem at ease. Testing. After design analysis and design optimization, the testing phase starts. Prototypes can be built in a laboratory or a computer to test the design. More often, prototypes built on computers are utilized because they are less expensive and faster to generate. The results of the engineering analysis and optimization phase are evaluated to check for any violations of provisions provided in the standard course of practice and other behavioral constraints. If there are any violations, the system is modified and analyzed again. This cycle of analysis and testing of response is repeated until a system with optimum performance is obtained. The physical model of the prototype is essential in the testing phase. Design communication and documentation. The last phase of the analysis sub-process is design communication and documentation, which involves preparation of drawings, reports, and presentation. In engineering, the process of drawing is linked with design. Any design is finally represented in the form of drawing so that construction or production can be carried out. Computers replace conventional manual drafting. The use of computers in the drafting process is recognized as a separate field called computer-aided drafting. Techniques and styles of preparation of drawings are modified when computers are used instead of conventional drafting tools. The benefits of the use of computers in the drafting process can be discussed under three main points. Number 1, speed. Number 2, modification. Number 3, storage. Speed. Utilization of a computer-aided drafting system can increase the drafting productivity significantly over conventional manual drafting. Modification. The use of computers can easily modify the existing drawing. If any changes are to be carried out, it can be done very fast using the editing features provided by the drafting program. Storage. Storage of drawing requires very little space, and the revision on a later date can be done much faster than the present manual techniques. Computer-aided drafting improves the consistency of the drawing because drawing produced at different times will be precisely similar. Once the drawing is created, it can be reproduced very fast. Para 1.5 Benefits of computer-aided design. Number 1. Increase productivity of the designer through the visualization of product and its component, sub-assemblies and related parts. Number 2. Reduction in the time necessary for the development of conceptual designing, analysis and documentation. Number 3. Integration between designing, analysis and manufacturer through the provision of common database. Number 4. Design errors can be eliminated at an early stage of design. Number 5. CAD improves documentation and standardization of engineering drawing. Number 6. Elimination of mundane and repetitive jobs. Number 7. CAD eliminates the tedious task of performing longhand mathematical manipulations. Number 8. CAD provides an opportunity for more alternative designs to be produced before a final production version is selected. Questions. Number 1. Discuss the benefits of CAD to engineering design as compared to conventional methods. Number 2. List and explain the potential benefits of CAD that may result after implementing the CAD system. Number 3. What are the different tasks involved in engineering design? Explain each one of them in brief. Number 4. What are the essential positive and negative aspects of using CAD? Tutorials. Number 1. Gather information about computer-aided design from the internet, refer YouTube, Google, Wikipedia, etc. and prepare the speech of 15 minutes on CAD. You can deliver this speech to students in secondary schools where you have studied. Number 2. Arrange brainstorming session with maximum 7 participants on questions asked on CAD in previous GATE exam. Prepare the report of a brainstorming session. Field study. Visit any industry manufacturing unit near to your place. Observe the use of computers in the production process in the industry. Write a detailed report on the visit. Write a comment on use of computer in the industry visited by you.